Okay, so this is for the next lesson, which is vertically launched projectiles on a level ground. So this is a little bit mediocre, but it is still pretty, um, I guess, hard to explain in a sense. So I'm just gonna give you an example here, and I'll teach you how to solve for this kind of projectile. So again, we're gonna use a piano, which is thrown upward at a 33-degree angle and at a rate of 18 meters per second. How long will it take for the piano to start going down and the ground? So, anyway, so again, visualize it first. This is important. So, as you can see, we have a 33-degree angle and the velocity, the initial velocity, is 18 meters per second. So, first of all, we know we're dealing with the y-axis and the x-axis because it is going up and going down again. So, firstly, we have to deal with the degree here because it changes the value if there's a degree. So first, we have to solve for Vix and Viy. So how are we supposed to do that? Let's say this is a vector. This blue line here is a hypotenuse vector, which is 18 meters per second or something. And we're actually trying to find this area. Hopefully you can see it. And also this area. So the first vector and the second vector. So what this implies is that this is the y and this is the x. And to find that, and since we have the 33-degree angle here, this is basically the same as trigonometry, or if you learn trigonometric functions, hypotenuse and cos theta and hypotenuse sine theta. So these will also to the adjacent, and then this is the opposite. So our opposite here is the y, and our adjacent here is the x. So that is exactly why we're going to be using that in our Vix and Viy. So all we need to do is solve for that. Since we already have the initial velocity, we're going to be using this Vi cos and then theta Vix, and then so Vix is 18 meters per second cos 33-degree angle, 33 degrees. For some reason I can't pronounce 33 degrees. Anyways, that will also give us 15.10 meters per second, I'm pretty sure. And then for the VIY, we're just gonna be using the same thing. Instead, we use the sine, which it's going to be this, and it's 9.8. Wow, very convenient actually. So let me fact check that if it's right. Okay, it is 9.80. So now that we have this, let's put that in the illustration. So what I'd like to do is split these parts into two. So here we're going to split this part, and then we first find here, right? This is the half time. So VI, VI, VF, VF, VI, VI, VF, VF. What I'm essentially doing is that these ones is going to be our X and Y's, X and Y, X and Y, and X and Y. Now you should know that the things that we just did, VIX and VY, that is going to be our initial of the entire, launching motion. I think that is going to be our value. So we already solved for VIX, so that is going to be 15.10. And we already solved for VIY, which is 9.8. I should use a smaller brush next time. So VFX, okay, here. VFX, VIX, basically every X is the same as this because it's just going in one direction and there's no changes in the X axis. But for VIY here on the half time will always be 0. VFY here and VIY here, these two will always be 0 because that is the peak of the piano. And for here, the final velocity, this will also be the same as the others. And then here we're gonna put a question mark because we don't know that. So now that we have some values in, let's start solving the questions. So how long will it take for the piano to start going down the ground? We are going to be using a different formula this time, and the reason is we only had a 0-degree angle on the horizontal launched projectiles, but then we have a degree here, so we're gonna do a different one. And as well as the other one, we're only going to be using the square root if the VI is equal to 0, which our VI is not. So here comes this list of equations we're going to be using. So T equals VFY minus VIY to G. This is essentially from the acceleration formula. It's just slightly, I guess, different. I mean, it's not actually different, it's just the letters are different. But you can tell pretty much. So T equals is the time. And then the VFY, we're only trying to solve for the half time here because it is far simpler to do that way, because if we maintain speed and time symmetry, basically if we try to solve this, all we have to do is multiply it by 2 to find this. So since we have that, all we need to do is to put 0 meters per second minus 9.8 meters per second over negative 9.8 meters per second squared. And wow, this is very convenient actually that we have 9.8. I swear it was a random number I just input, but that is basically equals to 1 second. Exactly 1. And if we're trying to find the distance or the time it took for it went up and down, all we have to do is multiply it by 2. So basically half time is 1 second, and then total time is 2 seconds. So there we go, we already answered number 1. Now for B, what is the piano peak of the piano string? I don't know who made these questions. Okay, so basically it's saying what is the peak of the piano? So that is dy. Our peak is going to be this area, this line here, which I drew a line already, and that is going to be dy. Now all we need to do is use this formula, which again, this is from the kinematics major formulas thing, so you really have to familiarize it already if you have, but you have to know when to use it. So we just need to substitute the values. Dy equals 0 meters per second again, because we're trying to find the half time, and VIY is 9.8 meters per second squared, 2 times negative 9.8 meters per second squared, and then that will basically be 4.9 meters. And yeah, that is it. Actually, it's 4 point around 0. I just rounded it up, but it was basically 4.89. So now that we have that, we already solved the second question. Now for the third is how far. So again, you can already tell. How far is the dx? So we are going to draw a line from here all the way to here, because that is going to be our dx. Now as you know, we are going to be using the total time for this, because it started from, we're adding the time from here and here, so we will be using this formula. So dx equals vix times t. This is the total time, so we're going to be using this formula. Vix is basically, we already solved it, 15.10, yeah, around this one. Remember, it's Vix and not Viy, so 15.10 meters per second times 2. We're using 2 seconds because that is a total time, so this should be TT actually. And that should also equals to 30.2 meters. Lastly, we have to find the final velocity of the piano. So really, we have already solved everything here apart from this question mark I labeled at the end. So we're just going to be using this formula, which is VFY equals VIY plus GT. VIY here is from the start of the whole launch thing. So I'm going to just use this. VIY, we already know, 9.8 meters per second plus negative 9.8 meters per second squared, and then for t we're going to be using 2 seconds as well, because that is our total expedition. So we just use a calculator here. The answer is negative 9.8. So wow, it's very convenient actually. So how do I actually cancel these out first? Let's start with the time. Basically, this got cancelled out, and you got left with seconds here. And then for here, the dy, you cancel out the time here. And since this is also cancelled out, so oh yeah, hold on. for here actually. This is basically meters squared per second squared, and then over meters per second squared. So you basically just cancel out these two and you get meters. For here, you cancel out the seconds, so you get meters, and then for here, you cancel out the s here, which is this and this, and if you add the units, they're still gonna retain, and so that's negative 9.8 meters per second. Alright, so you can copy the formula if you don't know, but you have to still remember this, and maybe I shall send a full list of all the formulas for horizontally and vertically launched projectiles. So this is just it. You can pause. You can ask me anything if you're confused. So, all right, bye.